In this video, we're going to cover balanced versus unbalanced forces. I'm going to first take a look at this object, which has no forces around it. And so this is a case of a balanced force situation because there's no forces acting on it. The second object does have two forces acting on it, and they are the same amount, but in opposite direction. So this is also balanced. Now we're going to have an object where it has four forces acting on it. So two in the vertical direction and two in the horizontal directions, and those two are balanced. So we're going to first take a look at balanced forces, situations where the forces are balanced. So in all three of these situations, we would say that the forces are balanced. When the forces are balanced, then the object will either be at rest or moving at constant velocity. And from Newton's first law, we know that an object at rest will stay at rest. An object that's moving will continue moving at constant velocity if there's no unbalanced forces. So if the forces are balanced, objects at rest will stay at rest. Objects in motion will continue in motion. Now, in all three of these situations, the forces are balanced. Therefore, they will continue their motion, their state of motion. And we have a symbol in these situations. We have a symbol which looks like this. Net force, this is the symbol. Sigma F is the symbol for net force equals 0. We call this situation equilibrium. Okay, so when the forces are balanced, we say that the object is in equilibrium. Okay, equilibrium. Okay, and equilibrium just means that all the forces are balanced. And so if it is at rest, it's going to stay at rest. If it's at constant velocity, it'll stay at constant velocity. And we have a special name for this type of equilibrium. When it's at rest, we call it static equilibrium. And if it is moving, we call it dynamic equilibrium. Okay, so an object that is at rest and forces are balanced will stay at rest, and we call that static equilibrium. Object is moving, forces are balanced. We say that it is in dynamic equilibrium. Okay. However, not in every situation are the forces balanced. So now we're going to take a look at some unbalanced force situation. So here we have an object, and we have a force downward. So an example of that would be like this tennis ball right here. When I let go of it, it falls. Okay, so there is a force acting on it. Forces are unbalanced. Here's another example where I have forces unbalanced. There is a force down, but I have a greater force going up. An example of that would be if I took this tennis ball and I lift it up. Okay, so I accelerate it upward. So that's an example of this. We could also have a unbalanced force that is two-dimensional. So there's a force to the right and a force up. Okay, so this is a situation right here of unbalanced forces. Unbalanced. So we're dealing with unbalanced forces here. Now, when the forces are unbalanced, it is not in equilibrium, and we say that the objects, and we know that the objects will be accelerating. So if the forces are unbalanced, then the object will be accelerating. We can also, when it's unbalanced, we can also write this, that the net force is not equal to 0. Okay, so unbalanced, the net force is not equal to 0. So what is the object doing? Well, there's a few possibilities. One is speeding up. So it could be speeding up. Okay. The net force could also be causing it to slow down. It could also be causing it to change direction. Right now, we're going to focus on the first two. We'll talk about changing direction a little later, but we're going to focus on the speeding up and slowing down. So an object that has an unbalanced force will be either speeding up or slowing down. Okay, so let's look at some examples. Here I have an object with 3 forces. 5 newtons going up and 5 newtons going down. Okay, so these are the forces. And a force, just a reminder, is a push or a pull. We also have a force to the left here. So 10 newtons. Okay, so an example of something like that would be these post-it notes. Okay, there's force going up from the table, pushing it up. Gravity's pulling it down. And then I'm using my finger to push it to the from on the side here. Okay, so I'm pushing it horizontally. So this object right here does have a net force, does have unbalanced forces because nothing is balancing the 10 newtons. All right. So we can say that the net force is equal to, all right, so these two balance, but I have this 10 newtons, so the net force is 10 newtons. We can also say that it's accelerating. So will it accelerate? Yes, it will accelerate. In this situation, it will accelerate. Okay, and is this object moving to the left or right? Okay, let's just, I mean, it could go up or down, but let's just consider left or right. Could this be going left or right? And the answer is it could go either. It could be going left or right. So here's an example. I could be pushing it to the left. Okay, so this would be an example of this example right here. I'm pushing it to the left, and you can see that it's speeding up. It wasn't moving, and I'm speeding it up to the left. Okay, or I could just use friction. So I'm going to push it a little bit. So friction's slowing it down. So friction is pushing it this way, and then so if it's going to the right, it's slowing down. Okay, so let's take a look at this situation. If this object were going to the right, and let's draw a little motion map here. So imagine I have a ticker tape here. Basically, the idea is that every second, this is going to make a little dot onto. We can make a little dot onto this ticker tape, and if the dots are getting farther apart, it means going faster. Getting closer, it means slower. And so on this one, if it's moving to the right, the dots are going to get closer and closer and closer together. Okay, you could kind of think of like a car having like a leak, a leaking oil. So as it's driving, it's kind of drip oil. If it's slowing down, the oil drips are getting closer. So as it's going to the right, if this object were going to the right and the force is to the left, it's going to slow down. If this object were going to the left and the net force is to the left, then it's going to speed up. So this motion map actually works for either way, if you're going to the right or to the left. Let's take a look at another situation here. And now this is, we're going to take a look at, we'll go make this 8 newtons to the right and 8 newtons to the left. Okay, so 8 newtons to the right. So this is a balance situation. So the net force is going to be equal 0. So net force is 0. If the net force is 0, we know it's an equilibrium, and so the acceleration is going to be 0. Okay, so no acceleration. If I create a motion map for this, the dots for this would be equally spaced. Okay, imagine a car with that oil leak going at constant speed. It's going to drip oil, equally spaced. And so this would represent the motion of this object if it were moving. Now this object could be moving to the right at constant velocity. It could be moving to the left at constant velocity. Okay, and it actually could be at rest. This object could be at rest where the forces are balanced. So there's a lot of possibilities there. Okay. All right. Next, we'll look at a problem that's two-dimensional. So 10 newtons down and 10 newtons going up. So this could be, for example, gravity and normal force. Okay, doesn't have to be, it could be. And then we have a force to the right. This could be a force of someone pulling on this object, and on the left, it could be friction, for example. Okay, right. And then, so the net force, what is the net force here? Okay, these two forces cancel out. When the forces are in opposite direction, we subtract them. So 10 minus 10 is 0, so that's 0 vertically. And then horizontally, we have 8 to the right, 2 to the left, so 8 minus 2 is 6. So the net force of this is going to be 6 newtons. Now, is this accelerating? Yes, it is. It is going to be accelerating. If there is a net force that's not 0, but it's something other than 0, then it will accelerate. Will it speed up, slow down? Well, it depends on the direction that it's moving. So let me create a motion map here. Okay. So the net force is going to be to the right. So the net force is 6 newtons to the right. So if it's moving to the right, it's going to speed up. So it's going in the direction of the net force, it's going to speed up. Okay, so it's going to speed up. These dots are going to get further and further apart. Okay. If it's going to the left, in the opposite direction of the net force, it'll slow down. So this motion map also works for this. So if it's moving to the left, it's going to slow down.